Hi, myself Ganesan, and now we are going to discuss about fatigue and dynamic tolerances. First, entering into the topic of fatigue and dynamic tolerances, first we are in a need to know what is meant by fatigue. Fatigue is nothing but a crack which is developed due to continuous as well as a cyclic load or unloading, which leads to a fracture. In order to maintain the strength of the material or any component, we have to increase the fatigue life of the component. So we are in a need to study about the fatigue and the dynamic tolerances. Here, when we are discussing about the fatigue, we have to be familiar with the life. We have to be familiar in the fatigue process. That is the fatigue tolerance. We have to be concentrated over the fatigue tolerances, which we can increase the life of the material by increasing the fatigue strength. Now, when we are discussing about the fatigue, here the graphical representation shows how the crack has been developed from the initial stage to a fracture. The first diagrammatic representation shows how the crack has been initially developed, and due to the excess loading with respect to its yield point stresses. Then, because of continuous as well as cyclic loading, this crack gets elongated, which leads to a fracture, which has been represented over this diagram. For this purpose, we are in a need to find out what is the fatigue strength of the material to sustain a life cycle of a material. For that, we are in a need to develop a S-N curve with respect to number of runs with the actual stresses applied on this material. Now, here a graph has been plotted with respect to aluminum material, whereas with respect to its yield point stresses, it has been subjected to a cyclic loading in a free state, so that we can find at what situation it gets fractured due to these small cracks which occurs over the surfaces. So that we are in a need to find out at what is the yield point stresses which will be acting over the material which are in a need to propagate fatigue, which are in a need to propagate the crack to a fracture. Here we can find out what is the maximum yield point limit which material can hold in order to maintain its strength. For this purpose, we are going into the fatigue and damage tolerances. Now we are in a need to study about the factors which are affecting the fatigue life. Here, when we are discussing about the fatigue life, since when a material or a component is being subjected to a cyclic loading and unloading with respect to excess amount of load or more stresses applied over a critical area or a complicated structures, it leads to a fracture, as well as the life of the component get distracted. So we are in a need to find out what are the factors which affects the fatigue life. We are in need to find out what are the stages, and we have to concentrate over in order to increase the fatigue life of the component. Here, the first one is the cyclic stress stage. Here, we have to first need to know what is the capability of a material or the strength of the material, so that it can sustain a load up to a limit, so that which will leads to a fracture. We are in need to reduce the applied load with respect to this yield point limit. Then comes to the geometry. We are in need to design a geometry when compared to a complex geometry or a complex component. The stresses will be acting at the complex area, as well as the grain size of this material, which will be the grain size will be affected, the minimum grain size will be affected by more stresses, so that the concentration has to be carried out over the complex geometries. We are also in need to consider about the material type. The material type in the sense, this material can be sustained up to a particular level, so that it cannot exceed or it cannot sustain after its yield point limit. So care should be taken on the material type also, as well as the residual stresses. Residual stresses in the sense, when it is when a force is applied over a body, it has to sustain a limit. So in order to sustain its limit, with respect to the surface quality, there may be some voids or some air gaps which will be developed during manufacturing process, such as casting or molding, which leads to a fatigue failure. Leads to a fatigue failure in order to increase, it will decrease the fatigue strength of the material. Now, the study of these fatigue mechanism, this fatigue failure to a fracture is known as the fracture mechanism. Now, what is meant by a fracture mechanism? Fracture mechanism is a process by which the propagation of a crack leads to a fracture. This fracture, which is obtained due to a continuous loading, is the study of a fracture mechanism. Here, the fracture mechanism is coming into a stage due to the applied load. Since the load can sustain due to the applied load, so that the material should be capable of its strength. With the load which is applied beyond its yield point limit, it leads to a fracture. These kinds of mechanical properties we will be learning in fracture mechanism also. Here, based on the size of the part also, we are dealing with the fatigue as well as the life of the fatigue will be increased or decreased. Based on this, the structural property of the material or a component will be studied in the fracture mechanism. Then, after finding out what are the activities which will reduce the fatigue life of the material, so that in order to improve it, we have in a need to go for a design against the fatigue life. Here, there are three principles carried out over here. Here, the stress below the threshold fatigue limit, in the sense, if the material is capable of, when a load is applied on a material, it will be sustained up to its elastic limit due to the applied load. If it exceeds its load, it does not regain its original position, which leads to a fracture. So we are in a need to apply the load within the threshold fatigue limit. Then next we are going to design the fixed life. Some of the manufacturers, while manufacturing the component itself, they will be specifying what is the actual life of the component, so that after, if you are involving this component into the mechanical activities, this will lead to a fracture. So the consideration should be taken while designing what are the activities to increase or decrease the fatigue life of the component. Another one is the replacing of the part. When we are discussing about the fatigue as well as the life of the component, the manufacturing of a component will specify us that this part is capable up to 2 months or 3 months, so that after some designing processes, we can regain its original position. Or else, if we are not in a need to change its design processes, it is not capable to we are not capable to design a component to its life. So we are replacing the component with the another component, which leads to a increasing of the fatigue life. Now we are going to discuss about the damage tolerances. What is meant by damage tolerances? Damage tolerance is nothing but propagation of a crack, so that damage tolerance is nothing but process which will be carried out to ability to sustain until the component is being replaced or replaced or repaired. This is the process which will be carried out in a damage tolerances. We can find out what are the ways which we can overcome to increase the fatigue life of a component. Here we are having some of the analysis part, so that we can overcome this fatigue life to improve the material properties as well as the life of the component. Here, first, before testing a component into a fatigue and damage tolerance, we have to assume a component and we have to test the component or a material using some internal damages. In the sense, we have to apply load until we are getting a yield point stress, so that with respect to at what condition it can maintain or it can sustain without its fracture. Thus, we have an assumption over the component or a part, so that we can find out what is the maximum yield point which the component will sustain without any fracture. Then we are discussing about the stress that causes the cracker geometry. Here, this denotes the load which we are applying over the complicated structures, which leads to a crack over the surfaces at the complicated areas. Now, we have to be in a need to know what are the loads which has to be applied at the complicated structures in order to maintain or increase the fatigue life of a component. Here we are discussing about the ability of the material and the largest crack on the part, which in the sense, if we can maintain the crack, or else in the sense we can lead this crack, we can maintain the crack without leading to its fracture. Based upon these activities, we can increase the fatigue life of a component. Here, the duration of life of the part also can be increased with the help of the properties which we can, which will sustain the defects, which will sustain the limits. Now, duration of life, assumptions of the failure in adjacent component. It is a main factor which is discussed in damage tolerance. Is nothing but if a part is failing, if a part is failing, the load which is applied over the part should not transfer the forces to the adjacent component or adjacent part, so that leads to the failure. So we are in a need to design the component with the adjacent ribs or adjacent frame, which in a need to which will not transfer the load to the which will not transfer this failure to this adjacent component or a ribs or a frame. With this, we are in clear about why manufacturing, before consideration, we are going into a fatigue and dynamic tolerances in the production process. We can find out how this helps us in a manufacturing plant in order to reduce or in order to increase the fatigue life of a material to get a better life of a product. With this, I end this section. Thank you.